In this lesson, section 4.2, we're just going to talk about the angles of the triangles. In the last lesson, we classified triangles by their angles and by their sides. We're not really going to talk about the sides in this lesson. In another lesson, we will. We'll do some more stuff with the sides. Right now, we're just going to concentrate on the angles of a triangle. I mentioned something on the last lesson on 4.1 that I said, oh, we're going to get to later. Well, now it's later, so now we're going to talk about it. What we're going to do, here's just a regular regular triangle. This is a just an acute triangle, it looks like. I don't care about the sides being isosceles or equilateral or anything like that, okay? I just am looking at this just a regular old triangle. I'll just tell you what this thing says first, and then we'll talk about why it's true. The first thing is called the triangle. It's the triangle angle sum. Now, different books name things differently, but this book names it this. Theorem. Theorem. Now, a theorem is just a rule. We talked about that before, about postulates versus theorems. It's just a rule in geometry, is basically all that is, okay? So that's the theorem. It's talking about the angle sum. What does that mean? What does sum mean? It means when you add things up. Well, what are we adding up? We're adding up the angles of a what? Triangle. Do you see how all that makes sense? So we're finding the sum of the angles of a triangle, which means if I added up angle 1 plus angle 2 plus angle 3, what is it going to add up to be? I could just sit here and tell you, and you probably already know, to tell you the truth. But what I'm going to do is we're going to do like a little thing called a proof. Now, we did skip chapter 2, and chapter 2 was kind of like an introduction to proofs, but I thought it would be okay if we skip chapter 2 because there's so many other things towards the end of the book that I wanted to get to. So I had to figure out what I was going to leave out, and I thought I could leave out some stuff from chapter 2. So in chapter 2, we talk about proofs, and we haven't really talked about them yet, but we're going to talk about them pretty heavy later on. But this is basically, it's a proof to this theorem. Now, what I did here, I drew a line purposely. I drew this line so that it was parallel to the bottom of this triangle, okay? So I drew it. I knew this was horizontal, so I drew a horizontal one. So I know that this line and this line are parallel to each other. Let's throw some other angles in here. Since I did 1, 2, and 3, let's make this angle 4, and let's make this angle 5. And I want to come up with some kind of relationship for the angle sum, for the sum of the three angles. 1 plus 2 plus 3. That's what I want. I want to add those up. Now understand, this does not mean this angle is 1 degree and 2 degrees and 3 degrees. This is just the name of the angle. It's just an easy way to name the angle. So let's see what we have. We got parallel lines. Now we know something about parallel lines and transversals. We've talked a lot about that kind of stuff. So let's take a look at what we can say. Here's two parallel lines cut by a transversal. Do you see that? So what do I know about, let's say, 5 and 3? Is there any kind of relationship? Hopefully you see it. Absolutely, they are equal to each other. And what's the reason? The reason is because they're alternate interior angles. And we had a theorem that talked about that. That's where we talked about a lot of different theorems. So alternate interior angles are equal to each other. So I know 3 and 5 are equal to each other if that line is parallel. What else do I know then? Well, I know that angle 1 and angle 4 are parallel or equal to each other. Now, they're not necessarily equal to these two, but they're equal to each other. So I'll put 2 arcs here. So I know that angle 1 is equal to angle 4. So let's write some of this stuff down. Let's say angle 1 equals angle 4. And let's say that angle 3 equals angle 5. Right? I know that because they are alternate interior angles, and I know if you have two parallel lines cut by transversal, the alternate interior angles are equal to each other. Now, what am I trying to do here? And I said it already. I don't know if you caught it or not. I want to take angle 1 plus angle 2 plus angle 3 and see what they actually add up to be. All right? So I don't have any numbers in here at all. So you're thinking, how in the world can I figure out what they add up to be? But let's take a look up here. Look at angle 4, angle 2, and angle 5. Do you see anything that's true about those? Look at that. Angle 4, and then 2, and then 5. What do they form? Yup, they form a straight line or a straight angle, don't they? What do we know about angles that make up a straight line? Now, it's not a linear pair because there's 3 of them, but we do know that angles that make up a straight line or a straight angle, okay, they add up to 180 degrees because a straight angle or a straight line is 180 degrees. That means what? That means that angle 4 plus angle 2 plus angle 5, forgot the angle symbol, plus angle 5 has to add up to 180 degrees. And they add up to 180 degrees because they are supplementary, or they form a straight line, okay? They form a straight angle. So any angles that form a straight angle add up to 180 degrees. So finally we got a number in there, and we got 180 degrees. But that still doesn't say anything about 1 and 3. I know 4, 2, and 5 add up to 180, but what about 1, 2, and 3? Well, let's go back to this stuff. Remember what we said angle 4 was? Angle 4 and angle 1 are equal to each other. So instead of saying angle 4, I could substitute, all right? I could replace angle 1 with angle 4. So instead of saying angle 4, now I could say angle 1. Now angle 2, I'm not going to replace that with anything because I don't know what else angle 2 is equal to. So I'm just going to write it angle 2. But what else can you say? Look at angle 5. Do I know what angle 5 is equal to? Yep, angle 5 is equal to angle 3. So I can say plus angle 3. And I substituted, see? 5 and 3 are the same, so I can replace one with the other. 4 and 1 are the same, I can replace one with the other. 2 we're not really going to mess with, we'll just keep it angle 2. So now look what I've done. Remember what my whole goal was? My goal was to find the sum of the angles of this triangle. Add up all the angles. Add up 1, 2, and 3. There it is. Angle 1 plus angle 2 plus angle 3 must equal what? 180 degrees. And there it is. So that's a proof. We just proved to you instead of just, and remember, theorems can be proven. Now, some are easier than others to prove, but theorems can be proven, and we just did that. We just proved that angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. What that means is this. It means in any triangle, okay? It didn't have to be just this. I could have used an obtuse, I could have used a right, I could have used any kind of triangle. Any triangle, the 3 angles of that triangle will always add up to 180 degrees. It doesn't matter what kind of triangle it is. All 3 angles will add up to 180 degrees. Let's do a couple examples with that fact, and then we'll do some other things as well. Okay, here's an example that uses what we just learned. So what we have to do is we have to find the measure of the numbered angles. So that would be angle 1, angle 2, and angle 3. We're going to find out how many degrees each of those angles are. And it gives you some other angles, and it tells you the measurement of those angles as well. So we use those. That's going to be a big hint. We're going to use that stuff in order to find angle 1, angle 2, and angle 3. So we're going to have 3 answers for this. You don't always have to start with angle 1, but I'm looking at this right now, and I'm thinking, you know what? Angle 1's probably the easier of the 3 to find right now. So let's find angle 1. I'm not even going to look to see it part of the 3 angles of a triangle. All of a sudden, I see angle 1, and I see it right next to that 57. So we just talked about this. What's true about 2 angles that make a straight line? And you need to look for that because that happens all the time. Always look for that. I mean, I remember last year some kids just couldn't see it. And then that was like the last thing they looked for. Then they finally saw it, pointed it out to them, and they're like, oh, okay, I keep forgetting about that. So don't forget about this. These 2 angles form a straight line right here. And so a straight line is 180 degrees. That means angle 1 plus 57 is 180 degrees. So how do I find angle 1? Well, if they add up to 180, I can just take 57 away from 180. All right, and so we just do our math, and there we go. So angle 1 is 123 degrees right there. Tell you what, let's just write it in. So I already got the 1 there. 123 degrees. All right, so that's one of the things that we had to find. Let's find another one. 2 or 3 is probably just as easy. It really doesn't make any difference if you do angle 2 or if you do angle 3. Let's get rid of this thing. Let's go down to angle 2. We'll just go in order, okay? So let's find angle 2. And you say, well, wait a minute, that doesn't add up to anything here. How in the world? It's just kind of sitting there by itself. But remember the lesson that we just finished doing. All three angles of this triangle add up to 180. That means this angle, this one, and this one, they all three add up to 180. So if I know two of them, what I can do is take these two away from 180, and this is what's left over. So here's the math. What I would do first, I would add these up first, 71 and 57. I would add them up. That's an 8 and that's a 12. So these two add up to 128. Now what I need to do is take those away from 180 because this is what's left over. Remember, all three add up to 180. So this is what's left over if I take 128 away from 180. So let's do that. 180 minus 128. Let's just do the math right here. We don't need a calculator, and that's a 5. So that's this angle right here. So these two are 128, but if I take them away from 180, I have whatever I'm left with here. And I'll tell you what, let's get rid of this circle first. If I can grab it, there we go. And this is 52 degrees. So I'm just going to write that in there. So that's 52 degrees. So we found 123 degrees, and we found this to be 52 degrees. Now we're ready to do angle 3, this angle right here. It's really the same exact math as what you did this angle 2 down here, the 52. So I've got this angle 3, I've got this angle and this angle. You see that triangle JLK? I've got those three angles. You know they all three add up to 180. So what I can do is I can add these up. That's what I probably would do. I would go 123 plus 28, all right, and that's what, 11, and that's 4 and 5 and 1. Or if you had a calculator, you could just go 180 minus 123 minus 28, all right? So if you're using a calculator, that's fine. I don't mind you using a calculator, but that's how you would do that. 180 minus 123 minus 28, and that's going to give you what's left over. Or you could just add these two together, 151, and take 151 away from 180. And so that's going to be a 9 and a 2, so that would be 29 degrees. So this angle right here would be 29 degrees. If you wanted to double check, throw it into the calculator, add the three angles together, add 29 and 28 and 123, and you should get 180 degrees. Same thing with these three. Add up 71, 57, and 52. If you do that, you should get all three angles adding up to 180 degrees. We're going to do another theorem here in a second, but I thought I'd get rid of all the junk that was all around it. And let's kind of inspect this just a little bit further. What I want you to do is I want you to take a look at this angle and compare it to this one right here. Okay? There's a reason for this, and I'm going to show you in a little bit. So this is 57 degrees, this is 29, this is 28. What if we took 29 and 28 and added them together? That would be a 7, carry the 1, and that would be a 57. Check this out. So angle 29 and 28, if I added them together, guess what they add up to be? They add up to be this angle right here, which is 57 degrees. Let's try it again. Let's get rid of all this blue stuff. Let's try it again, but now what I want you to do is I want you to take this angle, and then this one right here. See if there's any relationship with those three angles. Well, we added up those before, didn't we? So let's do this. Let's add these two together and see what we get. So we get 71 and 52. That's a 3 and that's a 12. Look at that. I think we're on to something, don't you? This angle and this angle add up to be this one right here, the one that's on the outside. That's pretty interesting, and that's actually so interesting that they make a theorem just for that situation. All right, so let's drop down and we'll take a look at a separate triangle. We'll talk a little bit about it, but I wanted you to see that it works up here before you even saw what the theorem said. Okay, here's like a simplified version of what we just saw. What I want you to do is I want you to look at this angle right here and compare it to this one and this one, angle 1 and 2 and 3. Now, what did we do before? We took those two angles that were furthest away from this, and what did we do to them? We added them together. Now, of course, this does not mean this is 1 degree, 2, and 3 degrees. It's just naming the angles to make it a little easier for us. So what did we do before? We said that this angle over here that was kind of further away from these two, if we add these two together, they should add up to this angle right here. And they absolutely will. So you could say that angle 1 equals angle 2 plus angle 3. I'll give this a name. We call this, see what I did? I took a triangle and I extended one of the sides, and I got this angle that's outside the triangle. So I'll call this an exterior angle. We've talked about exterior angles before. Now these angles, 2 and 3, they're both interior angles because they're inside the triangles. Okay, so that's an interior angle. But, well, so is this one. If I put a 4 right there, that would be an interior angle as well. But if you look at this angle right here, I'll put that 4 back, this is adjacent to angle 1. These two are not adjacent to angle 1. These two are further away from angle 1 than what angle 4 is. And so what I would do here is call these remote interior angles. Okay, you know the word remote. You use one almost every time you watch the television. I know myself, I have to have the remote when I'm watching TV, even if I'm not flipping channels. Still like to have the remote. Why? Because why do they call it a remote? Because you're far away from the TV. When I was a little kid, when I wanted to change a channel, guess what I would have to do? I'd actually have to get up off my couch or off the chair and walk over to the television and actually click the knob. Isn't that horrible? See how bad it was back in my day? Just kidding, of course, about it being bad, but you get the idea. Remote means you're farther away, remote control, or if you live in a remote part of town, you live far away from the town. So these are called remote interior angles. Remote, why? Because they're further away from angle 1 than this angle is right there. So what this theorem says is this, that the exterior angle is equal to the sum, there's that word again, means we add up, the sum of the two remote, that's supposed to be an O, remote interior angles. All right, so that's what our theorem says right there. And we already saw an example that it actually works in the problem before this. So whatever this angle is right here, these two will always add up to this exterior angle. Here's a quick example to demonstrate how this works. This is the exterior angle because it's on the outside. These are the two remote interior angles. So what's true about these two angles right here? They add up to be the exterior angle. So if I take x plus 50 and add them together, right? Take these two right here, add them, put a plus, add them together, they're going to equal the exterior angle, which is 2x minus 15. And now we can actually solve for x, and we can actually find what the angles in this triangle are actually equal to. So let's do it like this. Let's subtract an x from both sides right here, and let's add a 15 to both sides. And let's see what we get. That cancels. That's a 65. 2x minus x is just x, and this cancels, so x is equal to 65. So this angle right here is 65 degrees. Now look, I could take that 65 and throw it into this. Let's just do that. 2 times 65, that's 130 minus 15, which would be 115. So you could do it that way, or you could just add these two together, couldn't you? Because remember, these two add up to be what this angle is. So 65 and 50 is 115. So this angle right there is 115 degrees. And that's why this is very, very useful. There's ways of getting around this, but this really, really helps out. Okay, it's a real great tool to figure out what some missing angles are. So look for it. Look for a triangle. When you extend one of the sides, you have an exterior angle. Look for the two remote interior angles. Don't add this one right here. See this one? Don't add that one to it. It's the two that are furthest away from this exterior angle. Add those two together. It will equal this exterior angle. You can do your algebra, solve for x, and do what they need you to do. But that's really, really comes in helpful. I guess in helpful, that's not right. It's very helpful to you to be able to solve some of these problems. So make sure that you understand that. This next one's kind of common sense, to tell you the truth, if you think about it. But they call this thing a corollary. They call it the triangle. It's the same name as that other thing that we did. The triangle angle sum. Angle sum. And they call it a corollary. Make sure I spell it right. A-L. Corollary. There we go. Okay. So, actually, this should be an O. I thought I spelled that wrong. There we go. And that's an A and that's a Y if you can't read it. Okay, so it's the triangle angle sum corollary. Corollary basically means it's a theorem is really what it is. But what it does, it relates to something that we've already talked about. So we got this corollary. We got this little tiny theorem. It's kind of like a little mini theorem. We got it from something else that we've already learned, which is the triangle angle sum theorem. Right? Meaning, if I know that all three angles add up to 180 degrees, that's going to help you understand this. So let's just take a look. Remember what I said on this right triangle. We have one right angle. These two angles right here will be acute angles. So this right here is an acute angle. And this one right here is also an acute angle. But they're not just acute. We can get a little bit more specific with this. Instead of saying, they're just acute. We can actually find some kind of relationship between these two angles. Because look, how many degrees is that thing right there? Well, it's 90 degrees because it's a right angle. How many degrees do all three angles add up to be? They add up to be 180. Well, let's do this. Let's take away that 90. Well, what's 180 minus 90? Well, that's 90. So what must be true about this angle and this angle right here? They have to do what? Let's put some numbers in here. Put a 1 and a 2, right? Angle 1 plus, it's a weird angle symbol, plus angle 2, what do they have to add up to be? They have to add up to be 90, which means what kind of angles are they? That means that they are complementary angles. Complementary angles. So the acute angles, this is what it says. The acute angles of a right triangle are complementary. So if you have a right triangle, the other two, not the right one, but the other two have to add up to 90 degrees. And how is that helpful? Well, let's take a look. All right, got rid of all that mess. Let's just put some, let's put a degree in here. Let's say, we'll make it real easy. We'll say that's 30 degrees. I'll make it look like a 3 here. So we'll call it 30 degrees. Now there's a couple ways you could find this angle up here. We're going to try to find this missing angle. You could add these two up and take them away from 180. That would work, right? But understand, remember, what's true about the acute angles? They are complementary. So really, all you have to do is one step. One little subtraction is all you have to do. Remember, these two add up to 80. I'm sorry, 80. These two add up to 90. Add up to 90. So what can I do to those? If I know one angle, how can I find the other one? I can just take this one away from 90 degrees, and that would be 60. So if this is 30 degrees, that means this is 60 degrees. Now, you could have gone 180 minus 90 minus 30 and got 60. That would have been okay. But it's so much easier just knowing that those two angles add up to 90. Take this away from 90, and then you're good to go. See how easy that is? So use that. I'm giving you some real helpful hints that are going to come in handy later on when you're trying to solve for different things. Okay, here's the last example, and we will be finished. So we're trying to find the numbered angles. We're trying to find angle 1, angle 2, 3, and 4. So where do we start? Well, let's start with 1. Okay, that's a good place to start. If you look at this, it's part of a right triangle. Do you see this little skinny right triangle right here? This is a right triangle. This is 52 degrees. So how do I find the missing angle? Find the missing angle because I know that these two are complementary. So I can just take this, or take 52 away from 90 to find angle 1. So let's do that. So 90 minus 52, and that would be 38. So angle 1 right here would be 38 degrees. All right, not so bad. Let's do this. Let's go to angle 2. Yeah, we could do angle 2 because look, angle 2 is part of this triangle right here. That's also a right triangle. Here's what I'm trying to find. I'm trying to find this angle right here. Let's do this in a different color. I'm trying to find this angle right here. And I know this is 38. So I know that 38 and 2 are complementary. So I can take 38 away from 90. So I'm taking it away from 90, and that would be a 52. So this angle 2 right here is 52 2 degrees. Now, let's do angle 3. Check this out. It's not really part of one triangle, but it does make 90 degrees. Do you see this? There's the right angle. So angle 2 and 3 form a 90-degree angle. So guess what I can do? If this is 52, I can take 52 away from 90. And you should be able to do that without even doing the math, because you saw taking 38 away from 90 gives you 52. So if you take 52 away from 90, guess what it gives you? It gives you 38 degrees. So this angle right here is 38 degrees. And if you look at it, look, 38, 38, that must mean that you got parallel lines cut by a transversal. See, all that stuff's coming back, isn't it? Aren't you glad you learned that? Yep. Let's do angle 4. Now, if you take a look at this, if that's a right angle, that has to be a right angle as well. Let's go different color. We'll go this pink color. So if that's a right angle, that's a right angle. And so look, I've got this triangle right here. So if that's 38 and that's 90, guess what? I'm taking 38 away from 90, and I've already done that once, and it's 52. And so that angle right there is 52. See how it all works together? Look, 38 and 52 is 90. This 38 and 52, that makes a 90. This 38 and 52, that makes a 90. All right? Hopefully it's all coming together. All right, well, that's the kind of stuff that they're going to ask you to do. I believe that's the last thing. Yep. Sometimes they'll get a little more complicated than this. All right, so but it's the same basic foundation, the same basic rules that I'm teaching right here is you're gonna have to do on the homeworks. All right. Well, good luck on that, and I hope that makes sense. If you need extra help, stop, pause, go back, and listen to it again if I went too fast, especially with some of the math. Go to Khan Academy if you have any questions on this. Okay, just look. Type in whatever we're doing, angles of a triangle, type it in, and I bet you he'll go through a lot of this kind of stuff as well. All right, good luck with this lesson. We'll see you next time.